Hello everyone, I am Hussein Azizullahi and welcome to Pragmatic Programming channel. This is the second episode of C# programming tutorial. In this episode, I'm going to talk about how computers work. So now let's talk about operating systems. In general, an operating system is a software that manages computer hardware, software resources, and provides common services for computer programs. On the one hand, operating systems schedule tasks for efficient use of the system and may also include accounting software for cost allocation of processor time, mass storage, printing, and other resources. On the other hand, for hardware functions such as input and output and memory allocation, the operating system acts as an intermediary between programs and computer hardware. Although the application code is usually executed directly by the hardware and frequently makes system calls to an operating system function or is interpreted by it. There are some examples. As you guessed it, Windows, Linux, FreeBSD, and macOS are all examples of operating systems. Now, how your program works in an operating system. When you compile your program in Windows, the output file will be an exe file or a DLL file. These types of files are called executable files or EF. For example, they call their format in Windows Common Object File Format, or in short, and in Linux or FreeBSD they call it Executable and Linkable Format, or in short, ELF. These files include a lot of information about how to load this file to RAM, and it specifies where compiled codes are and where are the data that is required by those codes and how to put code and data in RAM and where to put the CPU execution pointer to run this code. So yes, when you compile your code into binaries that are only readable by CPU, then they must be bundled into a new file, which in Windows is called COFF, or in Linux they call it ELF. Now operating system load that file into the RAM and passes the CPU execution pointer as described. In single task operating systems, it is as simple as I described, but in modern operating systems, which are all multitask, the story is different. In multitask operating systems, it's important to be able to share CPU time between programs so that there is a service in each operating system core called a scheduler, which is responsible for time sharing of CPU execution time between each program. Now we shall talk about process, threads, and a bit about their internals. Each program that is loaded into RAM by operating system is called a process, and each process has a unique ID which will be used to distinguish between these processes for many reasons, including CPU time sharing. Each process has two types of memory, heap and the stack. Heap is shared throughout the process and the stack memory is shared within a specific scope of running code that I'm not going to talk about it in this video. I just want to mention that due to their nature, heap memory is slower than a stack memory. In the future videos, when we get our hands dirty to the code, I will talk about this even more. Now, what is thread? Thread is like process, but it's created inside a process to make multitasking even more available inside of our applications. Just like processes, threads also have their unique ID to be identified by operating system scheduler. Every process from their creation down into their destruction, they have different states. As you can see in the picture, once a process is created, it will reach to a state of ready. And once the scheduler of the operating system decides that now it's a time for this process to be run, the state of the process will change to the running until an interrupt happens by the scheduler that says, okay, your time is over for now, I'm gonna run another process. By doing so, a scheduler tries to create the illusion of running multiple processes at the same time. But it is not. They're running after each other. Now, what is a driver or service and what's the difference? Now let's see what a device driver is. Device drivers are more commonly known as a driver. A device driver or hardware driver is a group of programs that enable one or more hardware devices to communicate with the computer's operating system. Without drivers, the computer could not send or receive data correctly to hardware devices, such as a printer. But you might ask that our keyboard is a hardware and don't require installation of any driver. That's because of generic drivers that modern operating systems come with. Okay, now let's see what a service is. In general, a service refers to work that is performed by one or more people that benefits other. For example, Computer Hub performs the service of helping everyone with their computer-related program problems and questions. Another example is customer service, that is a department within a company that assists customers with general company-related questions. With computer software, a service is a software that performs automated tasks, responds to hardware events, or listens to data requests from other software. In an operating system, these services are often loaded automatically at the startup and run in the background without user interaction. For example, in Microsoft Windows, many services are loaded to accomplish different functions. They respond to user keyboard shortcuts, index and optimize the file system, and communicate with other devices on the local network. An example of Windows service is Messenger, who allows users to send messages to other Windows users. Now let's take a look at Windows operating system architecture. In this image, as you can see, there are many components, which we are not going to explain every part of it, but we're going to just explain the big picture of how it works, right? Your applications will run on user space or user mode, which is very limited, and in kernel space or kernel mode, the device drivers, the scheduler that we talked about, and many more operating system services will run inside of it. You might ask, what is the difference? The difference is that in user mode, you cannot run any hardware command, while in kernel mode or kernel space, your applications, your device drivers, or any other services that you run in kernel mode will have the full access to any part of your computer.